Hi, I'm Mrs. Motley, and this is the science cat, Ferg, and he's in an exceptionally good mood today because he is excited to do an experiment, and we're going to do it together, and I'm going to show you what's going on. Ferg, hi. Oh. Okay, well, Ferg is probably not going to help me. The science cat is not feeling it right now, so. Okay, bye, Ferg. Thank you for your help. So first of all, when we do a science experiment, we're going to need to have proper protective equipment. I wanted to thank one of my colleagues for making this lab coat. She designed the logo herself, and it's stylish, but it's also safe. Safety is important. And speaking of safety, I also have my Harry Potter safety goggles on. Not the clout goggles, although these are stylish and mildly interesting. They are not safe. So I am going to wear my goggles, I'm going to wear my gloves, and I have my materials in front of me. So the point of this experiment is to see how we can form a relationship with different atoms and molecules. Chemistry is so much fun because you can literally make the tiny particles that we can't see with our bare eyes come together and form a relationship. What I mean by that is like a chemical bond. And a chemical bond is when we are able to join two or more atoms together and they stick together by a part of their atomic structure called an electron. We'll learn more about that as we go into it, but it has a little something to do with positive and negative charges. So anyway, here's the fun stuff. So first things is I just need water. Water is a very friendly molecule. What I mean by friendly is it likes to bond with a lot of things. And it's pretty much a molecule that's like, oh, come, I want to stick to you. So it needs a friend. And what we're going to do is add another kind of substance called calcium chloride. For this experiment, you need some sort of salt. It can be calcium chloride or calcium lactate. Those work best. Calcium chloride is calcium stuck to chlorine. So I'm going to take my water, mix a couple spoonfuls. You don't need much. But water, like I said, is a friend to many molecules and atoms, and it easily dissolves them. This is called solubility. If it looks like it disappears, it means that the atoms of the water molecules are sticking to the particles of the calcium and chlorine. Add a little bit more. Calcium chloride is the stuff you put on your roads to melt salt. All right, so then the next part is that we're going to take another molecule, and I mixed it with water again, and it's a liquid. So we have two liquids here, liquid and liquid. I added color because color is much more fun, but I also kept it clear. This is what it looks like when it's not colored. I have capped all bottles because safety. And we're going to uncap them. So we'll take the blue first. All right. And then the clear. And then finally, we'll do the red. I seem to see something happening. Maybe if the camera would zoom in closer, we might be able to see some interacting molecules reacting together. And this is the end of part 1. And it's been not only 30 seconds later, and we're back. And the best thing about this experiment is that it's quick. So we don't have to wait long, because I know you're probably like, I don't have time for that. I'm just gonna fast forward to the end. I totally understand. So I will take my popsicle stick of science and carefully pick up this whole phenomena that seems to be going on in this beaker. Oh wow. Well, there's the end. Whoa. This is... What the? It's like this huge string, but I didn't put solid objects in this water. Will it ever end? Oh, good. Okay, thank God. And then we have more. So what happens is that you get this long chain of molecules. That long chain of molecules, they're all now chemically bonded together. This is called a polymer. A polymer is a long chain of molecules that pretty much are chemically bonded together in a long repeated pattern. And if you are interested in chemistry and cooking, this is also a field of culinary arts called molecular gastronomy. You can fill the liquid up with some kind of flavoring, and you can actually eat these. But in this case, because safety comes first, don't eat the lab. Now you're probably wondering what the heck this liquid is. It is the material that comes from the cell wall of seaweed and algae. And that cell wall is ground up and powdered up, and you mix it with water, and it's called sodium alginate. And what happens is sodium alginate mixes with the calcium chloride. The atoms and molecules bond together into a long repeated chain called a polymer. And that's why I have the spaghetti here. Not because I'm going to eat this with my spaghetti for dinner tonight, but it's demonstrating that a polymer can be a single chain, but sometimes you can add something else like sodium, like calcium chloride, and you can make the polymer chains come together. So if you've ever made slime before, that's a polymer. So thank you very much for watching, and that was making sodium alginate calcium chloride polymer chains. And Drogon, the science dragon, would like to add as a final ending that you can hide that panther pride.